Hello, this video is about normalized device coordinates. It is the fourth video in my themed Java development videos. I'm now going to step through a series of slides to introduce the project. This video is about normalized device coordinates. Descartes realized that he could determine the position of a fly on the ceiling by measuring the length from a reference point along each wall, providing there were right angles. Computer monitors in the past used raster scan technology, and the origin was set in the top left hand corner, and this is upside down compared to the Cartesian coordinate system, where the origin is in the bottom left hand corner. With NDC, it is possible to make the display surface appear to have the same dimensions, which is 0 to 1 along each axis. The author has employed some ideas in this book, the graphics kernel system. Typical native screen resolutions are 640x480, for example. This block of code shows how you get a graphics object down here, and then you measure the panel width and height, create a new object for normalized graphics, and then set up the normalized graphics system by giving it the G, the width and the height. This function is the drawLine function, and it illustrates how NDC works. You feed in floating point values, and then later on we're going to convert them into integer values required by the native graphics system. So if we look here, this section of code takes the floating point value in, multiplies it against the measured screen dimension, and then produces an integer value. This little bit here, 1 minus y1, is the part that is required to invert the y-axis. And now what we're doing, when we make a call here, we can draw a line. If we're going to draw a line using NDC from the origin, which is 0, 0, to halfway along the screen, in other words the center of the screen, we would use this sort of arrangement. The advantage of NDC is that it is portable. Code written to run on a PC or a tablet will also run on a laptop, and even with Android, although the headers required for Java are somewhat different. So NDC converts Java graphical coordinates to Cartesian coordinates. This slide shows the normalized device coordinates here, with the increasing value x moving in this direction and y in that direction, and the Java coordinate system where the origin is here and increasing value y go in this direction. There are two main classes in this project shown here, normg and NDC frame. An NDC is consistent with the coordinate system normally employed to represent equations in papers and textbooks. Here's a question that we can answer. The next slide is a demonstration of the NDC app running in Netbeans. This is Netbeans, and I've loaded the NDC app. I'll start off by running the app to show you what it can do. Here we have a line going from 0, 0 to 0.5, 0.5. Here we have an empty rectangle, a circle, the center is down here, an oval. This is the Polyline function, poly meaning more than one. This is the text on the screen with large font and some more text. Down here, this is what happens if you use the Java coordinate system. This is a draw line from 0, 0 to 100, 100. Right, so when you create the interface using the Builder tool, this is the location where your code has to go. What we're doing here is we're getting the panel graphics, setting the width and height, and then setting up the graphics for the normalized graphics, drawing a line between 0 and 0.5, drawing a circle, drawing the string with 2 different font sizes, filling a rectangle, drawing a rectangle, and here is the Polyline function. If I move over here, you can see the various functions. If I go to, for example, Polyline, you notice that Polyline has float values coming in, and there 2 variations here. This is an example of overloading. For example, if we look over here, there's Polyline. I'll show you now the design window. This is a design window. It's a simple window with a panel and a button. But if we go to the source, we can see that the generated code is hidden behind this switch here. So even though this is a fairly simple interface, the amount of generated code is quite large. With a more complex interface, the amount of code generated is significantly more. Well, I hope you found this interesting. Bye bye.